One of the interesting things about functions and data in general is that with some pieces of data, you can come up with more data points about that data, like metadata, right? So in this example, I have a pretend database of photographs, photograph files, right? So I have file name, dimensions, file size, description, and file folder. So that's the location on my computer where this file lives. But I have all these other things that I can create from this with functions. So for example, let's say dimensions. I have the width times the height, but we could create a width column and a height column from that. So this is going to be functions within functions. So just like you can put inputs into a function and get an output, you can put inputs into a function. You can put inputs into a function and then use that output as the input of the next function. So I have this function here, which is going to find the width 4032 out of the dimensions in cell F54, 4032 by 3024. So these functions have functions within those functions, so we need to break it down to understand it better. So the tactic I have for that is to take the innermost function and take it out. So we're going to say equals find x in F54. So what is this returning? It's saying that the fifth position in this cell contains x. So it's saying 1, 2, 3, 4, 5. That's where the x is. So we're putting it at the 5, okay? And then we're saying use the function left. So I'll put the left. So this is the find function, this is the left function, and then we have the value function. So left F54 5 minus 1, which is the result we want, and then value of that text as a number. So value returns it as a number. So what does this do? It says find where the x is and subtract 1 from it because we don't want the x. If I just say 5, it includes the x. So it's 5 minus 1. But if we use the formula inside of it, that's how we can drag this down, because not every single row is going to be at position 5 for the x, right? If the dimensions were 1, 2, 3 times 1, 2, 3, the position of the x would be 4, and the width would be the first 3 values. So we need left F54, 5 minus 1. I'm going to replace this now with the find. We don't need the other equals sign. So this is left of the x, 5 characters, minus 1, to get us down to left of the x, 4 characters, or 1 minus the location of the x as the number of characters from the left inwards. So that is the value, and that is how you get this one. And because we used the find function to dynamically find where the x is, we can click and drag it, and it works across rows. And if these change, even 40, it's going to be 40, because the x is now 3 characters in from the left as opposed to 5. I'm going to return that to its original state. So that's width. And then for the height, it's going to be, I think it should be the right function with the same parameters, because we really just need to go from the right. You could also go from the left, but further in, right? But we're going to go from the right. How many characters in from the right is x? 5 again, minus 1 is 4. Return character 1 through 4 from the right, which is the height, 3024. And then we're going to drag that down. Now, file type. Dynamically, we could do something similar to what we did over here, where we have a big function containing other functions, and we're going to break it down. Let's find E54. At what point is the period? So 14 characters in from the left is the period. And then if we use len, which is the length of something, we can find the total length, which is 17. So then 17 minus the location of the period equals the size, equals all of the characters of the extension at the end after the period. So we're going to then say equals write len file name minus find period there. I need one other thing. I need E54 again. Okay, so what does this all mean? This means I'm taking the length of E54, the full word file name, M plus O plus R, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the file name is 17 characters long. And then I'm subtracting from that where the period is found, which is 14 characters in. So then it says, okay, I want 3 characters. And from what direction do I want them? From the right. So JPEG is 3 characters long. It's 1 through 3 characters in from the right. So this is why write len minus find equals the actual extension. So we're going to do that and press enter. I'm going to copy this whole formula, clean these up, and I will drop it in here. So now this is the JPEG file type, and anything else that these are will be appropriately named. If I do JPEG, it would actually be different. We could standardize that later on. We could actually do replace or substitute. JPEG for JPEG. So we'll wrap that whole function in another function that substitutes anytime it's JPEG with JPG, so that it's all the same. And to test that, we have one that's JPEG and it's coming out as JPG. JPG coming out as JPG again. JP coming out as JP. That's not, or that is actually accurate. So let's say this is a PNG, comes out as PNG over here. And if we have a JPEG spelled JPEG, that should be JPG. These are the same file type, so we're going to keep it the same. and that works. I'm going to change a couple of these just to demonstrate that it's all working. We'll do a PNG, we'll do a GIF, and JPEG. So now we have all of our test scenarios showing up over here as coming out according to expectations. So another thing I can do, if I have the file folder, users, Riley, pictures, photography, morning, then the file name at the end of that is the actual location of the file. So let's go equals. You can do a couple things here. There's a few options. One is file folder, ampersand file name is going to place the file name at the end of the file folder, / morning light right there. Another option is concat, which is concatenation. So a couple strings get combined together, and that's going to be comma separated since it's a function as such. And you can also spell it concatenate. These do behave a little differently, but it won't matter for this example. Just to have those different examples, I'm going to use each one. All right, and I'll drag concat down. So those are going to be the file locations using the file name. We'll do a little bit more math here. So the file size in megabytes is 3.8. Kilobytes are 1024 kilobytes per megabyte. So we're going to do equals 3.8 times 1024. That would be the file size in kilobytes. Let's say we also want to round it. We're just going to say round, parentheses, and we'll do 0 decimal places. All right, so that's a file size in kilobytes. We will drag that down. And then the file size in gigabytes is the opposite because there are 1024 megabytes in a gigabyte. So we will do 3.8 G54 divided by 1024, and that equals this small fraction. I'm going to do round again on this, but in this case we'll do 4 decimal places since it's a small decimal. And I will pull this down. All right, and then the file name normalized was actually this example of the JPEG, so I'm gonna delete this column. Okay, so as you can see, let's say you had 10,000 rows, right? You wouldn't want to manually find the first 4 characters to find the widths. You wouldn't want to, 1 row at a time, multiply 3.8 by 1024. You wouldn't want to manually copy paste the morning light file name and paste it at the end of the file folder. All of these things are ways that you can automatically get more information out of information you already have. So you have one piece of information about an object in one format, and you can make more parameters about it. You could then find, like, for example, if I highlight all of this, I can now find what the largest height of my images are. So 4,000 down here. If I highlight these are strings, they're not numbers. So I wouldn't be able to know that information. Because this is a number 2, I can do the same thing and find the largest width of 6,000. File size, I can do max, average, min, can find this information about my files. So yeah, that's a couple examples of how to use functions to come up with more information about your files and to work through your different pieces of information and come up with greater insights, have more productivity in your workflows. And I hope you enjoyed watching. Thanks.